So those are the examples of the types of plots that I was going to show you. The only other thing I wanted to show was how you could generate a PDF containing those plots. I have created a short section that just repeats the code from above that's necessary to create what I think of as like each of the 5 best plots that I've demonstrated so far. So not like the histogram, for example, but some of the plots that required some setup, plus a few additional tweaks. And this code assumes that the dataset DAT already exists. So that's the fake data that I created initially. But it doesn't depend on anything else in this file. So all the rest of this was just demonstration. If you opened this syntax file and just ran the generation of the fake data and the standard error function right here, and then skipped all the way down to the PDF section, it would work fine. The key thing I'm introducing here is this function that's just called PDF, which I find very useful for handling plots because it presents everything in a standardized way so that the size and shape of the plot, for example, does not depend on the size and shape of the ad hoc plotting device that I'm working with at the time. Like when I generated this plot over here, it just popped up a window in my R interface. Or if you're doing it in RStudio, it's going to use the little plotting space in the lower right corner of the RStudio interface. So here I'm telling R to create a PDF that's called 5dog-related-plots.pdf in the current working directory, and the pages of that PDF are going to be 6 by 6 inches. I just tend to choose page dimensions that will work well for the plots that I'm going to generate. I'm not going to like share the PDF itself, the PDF with other people or like with a journal or whatever. The PDF is just a way for me to get the plots in a standardized way so that I can then import them from that PDF into whatever other document I'm using for my manuscript. Okay, so here is that line of code. I run it and it doesn't appear to do anything, but R has created that file and is waiting to populate it with stuff. So I want to make sure I don't run a bunch of lines like this and not end them. So I finish creating that PDF with this line right here, dev.off. That ends the current graphics device is what will tell R to finalize that PDF file that it's working on. In between, I have all the stuff that I need to generate the PDF. This stuff, it doesn't have to be within the PDF. You can run arbitrary code after running the PDF command. So this stuff just recreates the MSE mod min-max wags and fitted borks variables that I used before as utility variables in creating the plots. So I'm going to run those again. That's just to make it possible to skip all of the demonstration stuff I did up here and go straight to the generation of the PDF. And then I have my box plot, which starts with a par command that sets up a new graphics device, a new page of the PDF, and does the box plot that I want to do. The bar plot from before, which again starts with par, sets up a new page. The individual points with means. The shaded scatter plot, and the color-coded scatter plot with jitter. And then finally dev.off, which just finishes creating the PDF. And the result of that should be this. So I'm opening this in my just default PDF viewer on my computer. Here's the first plot. This is a 6 by 6 inch page. The point is that I could manipulate this PDF in the way that I would manipulate any other PDF. So here's my box plot. Here's the next page of the PDF contains the bar plot with the standard error bars. The next page is this graph that I created representing the means and of each of the distributions for the dog types. The shaded scatter plot with a regression line, the color-coded one with a regression line, and that's it. So those are the 5 example plots included in this PDF. And if I want to put one in like a Word document, I would probably just zoom into 100% and copy it as an image. There's of course a few other things that you could do to accomplish that. it seems like we've finished up the stuff that I had planned for this workshop. The plotting demo that I went through today, there are lots of useful plotting functions out there. So ggplot2 is probably the most popular among people that I talk to on a regular basis. There are lots of others. If you're doing like bioinformatics, there will be plotting functions built into the packages that you use routinely to do the statistics that you want to do. If you do neuro stuff, I'm sure that there are packages built that generate nice images related to that. But what I'm trying to convey here is that the base R plotting functions can do quite a lot, and there's no reason to be shy about using them if they accomplish your purpose. But also be aware of all the packages out there that can make certain things handy for you.